Okay, class. So can you see the file, right? Can, okay. So yesterday we learned about introduction of quantum physics. Okay. Did I start recording? Is it recording? Recording. It's recording. Okay. So we learned about what is meant by photon. What is photon? It's a packet of energy of an EM radiation. So we learn about photon. What is meant by photon? It's a packet of energy, and it's found to be, the formula is HF, and F replaced with CO lambda, so HCO lambda. Okay, this is photon energy. Okay, then after that we talk about why the concept of photon is brought in, because of one controversial experiment called photoelectric emission. Photoelectric emission, and we found that some experimental outcome against the wave theory. Okay, the main one is here is the time lag, number 5. Okay, there is no time lag. Then there is existence of threshold frequency, number 2. Okay, and the kinetic energy or the release of electron independent of intensity. Okay, that's 3 factors. Then Einstein came out and he explained the photoelectric effect by using this formula. Okay, so photon energy is used for work function plus EK max, okay, kinetic energy of the electron. Okay, today's lesson, we're going to further discuss about this, okay, this equation. Okay, so that's today's lesson. So we go to the PowerPoint now. Okay, so the Einstein 3, the HF is equals to work function plus half mv squared. So now, as I told you, Einstein got problem to prove this. Because what you want to prove, you need to prove this equation is correct. For the equation to be correct, what need to be calculated? He can work out the frequency. Frequency, we know what light you shine. What light you shine, the frequency of the light we get to know. Okay. Work function, we don't know. Work function, difficult to calculate the work function. How much of energy is used for bonding? We are unsure about the work function. Okay. But if we have a technique to measure kinetic energy of the electron which comes out, the kinetic energy of the electron which comes out. So I think we can able to prove this equation. Okay, linearity, right? Let's say HF equals to work function plus half mv squared. Okay, so HF over E equals to work function over E. Half mv squared. So Einstein don't have idea how to find the kinetic energy. So later, I think after 15 years later, Millikan, as I said, Millikan said he able to find the kinetic energy of the electron which is coming out. Okay, so he said he's a pioneer of using electric field. Millikan. Actually, Millikan's aim is not to prove Einstein is correct, but to prove that Einstein is wrong. Okay, he want to prove that Einstein is wrong for the first time, because Einstein is quite famous at that moment. So his ideas are everyone like later found to be correct. So you want to prove that Einstein is wrong at this point. So what he said, he developed this experiment, this setup, and Millikan said we can find the kinetic energy of the electron by using the right hand side rod as a cathode. Okay, for example, you see I shine with a certain intensity, so light comes in, photon absorb, electron comes out. Okay, yeah, I put I rise the intensity, the number of photons rises. Okay, so more electron. Okay, now we want to find what speed the electron comes forward. Okay, so what Millikan said, he said use this voltage. voltage, put the right hand side as a cathode. So put a negative voltage. Put a negative voltage. Put a negative voltage. Negative voltage means the right hand side rod become cathode. So when the electron release, right? When the electron release, the electron move forward. The electron will have its kinetic energy. Will have its kinetic energy. But if you put this as a cathode, the right hand side as cathode, what happened to the electron? What will happen to the electron? The electron will slow down. See, I put here now it's negative 0.4. I put big voltage. I raise it. You see, 0.5, make it 0.8. You see, the electron all slows down. Why it slows down? Why it slows down? You know this, right? Sorry. You know this, right? When you put a parallel plate, when you have a parallel plate, electron has its own kinetic energy. When it move forward, okay, if you make it this as a cathode, what happened? The kinetic energy of the electron, the change in kinetic energy of the electron will be equals to what? Anybody? Work done? Work done by the electric field, right? Work done by the electric field. So the field does work. What is the work done by the electric field formula? The AS knowledge. Anybody? QE, right? Q changes in potential. Okay. So the voltage is what? The voltage is voltage between the plate. Voltage between the plate. The voltage of the between the plate is raised. What happened? The V is raised. What happened? The kinetic energy of the electron will change more. So we find the voltage where the entire kinetic energy of the electron is converted to work done. How to know all the kinetic energy of the electron is changed to work done? Work done. How we to know? We get to know that by checking the current here. This current is 0.117. This what is the meaning of that? Electron still some electron reaching the plate and causes the current. So we haven't find the potential, right? So what do you do? This negative 0.8, right? We rise further. We rise a little. We put it further until the current for the first time become what? Become 0. When the current becomes 0, what is the conclusion? The most energetic electron has been stopped reaching the plate. That means not even one electron get into the wire. That potential called stopping potential. Okay, what is stopping potential? A potential, the minimum potential required for the photocurrent become 0. When the photocurrent becomes 0, we say the most energetic electron supposed to reach the plate stopped. Okay, you see this negative 0.8. I increase it further. Negative 0.1 still got current. I increase it further. Here, negative 1.6 0 current. I want the minimum one. Negative 1.2 got current. Negative 1.4. Let me try with negative 1.4. Negative 1.4. Negative 1.4. The current for the first time become 0. So this is what predicted. All electron which is moving forward, its kinetic energy converted to work done by the electric field. When the electron just come to the plate here, it stopped. Just stop. Okay. So Millikan said Einstein faced problem finding the kinetic energy of the electron. Now Millikan said we can find the kinetic energy of the electron is same as Q. Q is what? The charge of the electron, in this case is E. The V labeled as stop VS. We call it VS. It's called stopping potential. It's called what? Stopping potential. Okay, it's called stopping potential. So Millikan does this experiment, shine the light, just change this voltage until the first voltage photocurrent becomes 0, but the right hand side electrode must become cathode. Don't make it anode, it's cathode. Then he measured the voltage here, E times the voltage. is the kinetic energy of the electron. Okay, now the kinetic energy of the electron. Okay, now got some trick part. I go to the slide. Okay, see the slide. So Millikan said the half mv squared is totally can be replaced with EV naught, EV naught or VEBS. EV naught. V naught is stopping potential. The stopping potential. Potential, the minimum potential required for the entire kinetic energy of the electron is converted to work done. Work done by the field. Okay, now so that's why EV naught. Okay, so according to Millikan, if the kinetic energy changed to EV naught, so the equation become what? Equation become HF equals to work function EV naught. Okay, so here, which is your manipulated? Which is the variable responding variable? The manipulated is frequency. Yeah, manipulate the frequency. How do you manipulate the frequency? How do you manipulate the frequency? By changing the source. The source shining on the metal plate, that frequency is altered. Increase, decrease, you change the frequency. So frequency altered. The photon energy, the packet photon energy changed. Big frequency means big photon, right? Big energy in one photon. So the kinetic energy of the electron going to be big. When the kinetic energy go forward, the stopping potential is measured by adjusting just now the device I told you. So F is what? F is the manipulated one. What is responding? Responding is the stopping potential. Stopping potential. So Millikan said, okay, we rearrange this formula. He said to bring the E down, divide by the E, all the equations. So it's going to become like this. We arrange this. So V naught, if we plot V naught versus frequency, okay, which is Y equals to mx plus C. So Millikan said, if Einstein is correct, if we plot V naught versus frequency, it must be a straight line. It must be a straight line where the gradient is h over E. H is what? H is Planck constant. E is what? E also is a elementary charge. Both are constant word. So gradient must be constant. And this is work function over E is the y-intercept. So anyway, it must be a straight line according to Millikan. So when Millikan do this experiment, changing F and changing V naught, he thought it's not going to be a straight line. But what happened? A straight line is formed. Okay, a straight line is formed. So when a straight line is formed, that shows that Einstein's theory is applicable. It applies. Okay. So the gradient is what? From this graph, the gradient is h over E. H over E is the gradient. Okay. And the y-intercept is what? Y-intercept is work function over E. And the x-intercept, this x-intercept, the frequency where the kinetic energy is 0, this F is called threshold frequency. It is called threshold frequency. What is threshold frequency? Threshold frequency. Threshold frequency is the minimum frequency required to release an electron from a metal surface without any kinetic energy. That's called threshold frequency. Okay, and Millikan got this straight line. He was not happy. His aim is to prove that Einstein is wrong, but failed. But he's not happy. But still, he want to do this experiment again by changing the metal plate. He changed the metal plate. Put another metal plate. Use another metal plate. Let's say first time you use a metal plate A. This is the graph for metal plate A. Now you choose another metal plate B, where the metal plate B work function is greater than the metal plate A. Metal plate B has a greater work function than metal plate A. How do you think the graph going to change? If you have a metal plate B which has a greater work function, okay, according to Einstein, if Einstein's idea is correct, means how is the graph going to change?
Shift higher.
Shift to where? Shift to the right or to shift to the left?
Since negative value,
Does the work function get bigger or smaller?
shift to the right.
Shift to the right. Very good. It shift to the right. The graph shift to the right. Gradient, any change to the gradient?
No.
No change. The gradient is still HOE. So the graph should shift to the right because it become more negative y-intercept. Okay, work function is big one. So the threshold frequency also get big lah. Big work function means big threshold frequency. So the graph should shift to the right without changing any gradient. So Millikan does experiment with another metal plate with a greater work function. The graph was shifted to the right. So Einstein was correct. So then he's correct lah. So they award him a Nobel Prize for this discovery. Okay. Now you must understand the half mv squared replaced with EV naught. Okay. The work function, right? The work function is replaced with HF naught. Work function is what? HF naught. What is F naught? F naught is threshold frequency. Okay. Threshold frequency. So this is the story of Millikan and Einstein. Now let's go further. The light shine, the metal plate, electron move forward, the collector tend to become cathode to get the stopping potential. How to know they achieve the stopping potential? The potential here adjusted, increase slowly until the current, photocurrent for the first time become 0. Now that's the stopping potential. Okay, now the kinetic energy of the photoelectron. Okay, the collector plate is made negative, so that when the photoelectron move towards it, there will be a loss their kinetic energy in potential energies. So the change in kinetic energy is equals to work done by the field, EV. So this how the stopping potential is kinetic energy is calculated. Okay. The current flowing through the circuit is measured with a microammeter. Where we use very because the current will be very small. That's why we use microammeter. Because the number of electron comes out due to photoelectric effects very little. Okay. The voltage between the emitter and the collector plate is gradually increased until the current drops to 0. The minimum value of potential difference necessary to stop the electron flow known as stopping potential. Okay. If the same experiment, if the experiment is repeated with the radiation greater intensity, okay, now question starts. Okay. Now look at the last point. Look at the last point. Do you understand the last wording? If the experiment is repeated with radiation of greater intensity, but same frequency, the maximum current in the microammeter increase, but stopping potential unchanged. Why? Okay, why this happened? The greater intensity, same frequency. Maximum current increase, but stopping potential unchanged. Okay, what they did? Let me show you here. Put the animation again. What has been done? The intensity is increased. Intensity, I have the intensity here. You see up here is the intensity. The intensity, I put here. Put the current is flowing first. Flowing first. Okay. So first, what they said, I increase the intensity. When you increase the intensity, you see, when intensity increase, what happened to the photocurrent? See, I increase the intensity. Intensity low, 0.04. I increase the intensity now. Check the photocurrent. And you photocurrent is getting a what? Photocurrent is increasing, right? Why the photocurrent is increasing? Can anyone explain this? Why photocurrent is increasing?
There is more electron flow.
There is more electron flow. Why there is more electron flow?
The intensity is directly proportional to the number of electron being released.
Very good. The intensity is actually directly proportional to the number of photons. Number of photons. Intensity is what? Energy, what? Power over area. So energy over area time. So energy energy is NHF over area time. So intensity proportional to what? Number of photon release. Okay. You have more intensity means you get more photon and get bigger and more photon. Maybe the photon 1,000 now become maybe 10,000. So the more electron will get photons, so more an electron will be released. So you know current. Current is what? Current is rate of flow of charge. What? More charge flows in a second, more current is produced. More current produced. In your exam, they won't focus to the photocurrent. They will ask how many electron release, how intensity affects the number of electron release. They say intensity proportional to the number of photon release. Okay? Greater the intensity, greater the photon, greater the electron is released. That's one. Okay, that's what we are proving here. That's what's the question. And the radiation is greater the intensity, but same frequency, the maximum current increase. Why maximum current increase? More photon, more electron is released, so more current. But the stopping potential is unchanged. Okay, this I haven't demonstrated that yet. Here, stopping potential. So stopping potential down here, I put negative. I put negative. We see the negative. Which negative gives you zero current? Sorry, not 1.6. I think 1.4. 1.4 slowly. Oh, 1.4 current. 1.6. Negative 1.6. For that high intensity, current is zero. So the stopping potential is 1.6. So stopping potential 1.6 means what you can say. It means the kinetic energy of the electron, which is coming, reaching the plate, EVS, the VS is about 1.6. Okay. Now you see, I change the intensity. The intensity up here, it dropped down. What happened to the stopping potential? It drops lower intensity. Low intensity. Yeah. Stopping potential, you see again. I put 1.4, got current. I put 1.6, again 1.6 lah. 1.6, current becomes zero. So stopping potential unchanged. So why stopping potential unchanged? HF equals to work function plus EVS, kinetic energy. Okay. When you rise intensity, the number of photons increase. But energy in one photon, any change? Energy kept in one photon does not change. So HF, no change. Okay, no change in energy in one photon. So electron receives the same amount of energy. The packet, energy in one packet is the same. So the electron has the same energy, same HF. The work function also the same. So stopping potential unchanged now. Okay. So intensity increase, it increase the number of photon. Number of photon is rise, but what? Kinetic energy unchanged. Kinetic energy unchanged. So VS unchanged. Okay, VS stopping potential unchanged. Okay. So now ask you more questions. A few more questions. Intensity increased. Intensity is increased. Okay. Frequency is decreased. Intensity is increased. Intensity increased. Okay. Oh, I read a question here. Intensity increased. Frequency decreased. Okay. That means the light from UV I change to red. But intensity I rise it. More brighter light. Intensity increased, frequency decreased. What is the effect to the stopping potential and the number of photon release? Okay. Anybody? Intensity is increased, frequency decreased. Yeah.
The stopping potential decreases.
Stopping potential decreases. Stopping potential decreases. Number of photon?
Increases.
Number of photon increases. Okay. Why? So we need to link the formula which linking intensity and frequency. Intensity is what? Energy over area time. So intensity energy is what? NHF over area time. Okay. This is the formula can predict our outcome. So we make N as the subject. N as a subject. N over T. We make N over T as a subject. N over T as the subject. So what's the equation going to be? It's going to be IA over HF. HF. Yeah, so this formula. N over T tells you what? The number of photon release per second. It depends to this formula. If intensity is increased and frequency decrease, okay, so this shows that the N over T will increase. So more photon will release per second. The number of photon rises. So to check number of photons goes up or goes down, this is the formula you need to think. You need to think, check number of photon per second, how much is released. Okay. But VS stopping potential, you don't need to worry about intensity. Stopping potential, you think about which formula? Kinetic energy is equal to what? EVS. Kinetic energy just directly proportional to EVS, stopping potential. So, but stopping potential, sorry, not this formula. Stopping, actually, you use the Einstein formula. Sorry. HF equals to work function plus EVS. When frequency decreased, frequency goes down. So stopping potential goes down. Just use Einstein's formula to find the stopping potential. Stopping potential only affected by the frequency, the energy in one packet of photon. And also work function, but work function is constant for that metal plate. Yeah. So yeah, this is how you visualize it. Okay. When intensity goes up, frequency goes down. What happened to stopping potential? Stopping potential just depend to frequency. Okay. Stopping potential, is it anything to do with intensity? Is it stopping potential anything to do with intensity? No, nothing to do with intensity. Stopping potential only about frequency. But how about number of photon released per second? Is it depend to intensity? Yes. Is it depend to frequency? Guys, I need your answer. Is it N depends to frequency?
No.
You see this formula? The number of photon depends to frequency. N over T. Also depend to frequency, right? You see, if frequency is lower, the number of photon become higher. So conclusion is, remember, the number of photon per unit time, the number of photon released per unit time, it's not only depend to intensity, it also depend to what? Depend to frequency. Okay, frequency affects the number of photon. Frequency also affects the stopping potential. That's the point I'm trying to highlight here. Frequency affects the number of photon per second. The frequency also affects the stopping potential. But intensity only affects the number of photons per unit time. Intensity doesn't affect the stopping potential. Okay, guys. So this is the something new idea for you to understand. Okay, so let me ask you further question. intensity unchanged. Intensity unchanged. Frequency raised. It means what? The metal plate shine with certain intensity unchanged, but frequency is rise. Frequency rise means we change the color from red, we go to UV violet, we rise the frequency. What happened to the stopping potential and number of photon per unit time? Number of electron release per unit time? Anyone? Stopping potential? What happened?
Increase.
Increase. Stopping potential, increase. NOT? NOT, you go back to this formula. NOT is what? NOT is IA over HF. So when F increases, NOT drops. So the number of electron, NOT is actually number of photon per second, is same as number of electron release per second. So number of photon, number of electron release per second drops. Yes, you get less electron reach the wire. Okay, please include this formula. NHF over AT for intensity. Okay. So, yeah, I hope you understand. Go back to the slide. So, yeah, that's why the last point. If the experiment is repeated with a radiation of greater intensity, but same frequency, maximum current or the number of electron per unit time increases, but the stopping potential unchanged. Okay. Any question from this slide?
Teacher, why when the frequency decreases, the number of photons increases?
Frequency decreases, number of photon increases. All from this formula, right?
But doesn't the frequency indicates how much the energy possessed in one packet of the photon, and then when the energy increases, why does it affect how many electron gets the energy?
Okay. So we can explain to another way. Another way. You see, intensity means what? Intensity means what? How much of what per meter? Strikes the second per second, strikes the surface in a second for per meter square of area. So 1 joule of energy, strike the surface of area of 1 meter square. Okay, 1 joule of energy. That 1 joule of energy, okay, let's say instead of 1 joule, I put EV. Let's say I put EV better. I put 1000 EV, let's say 1000 EV. The 1000 EV of energy strikes the surface every 1 second. This 1000 EV is in terms of packet. Okay, this is in terms of packet. Okay, let's say the 1 packet energy is how much? HF. Okay, let's say 1 packet energy HF, let's say it's 10 EV. Let's say the F is such that 10 EV. Okay, so how many photons strikes this surface in a second? So 1000 EV divided by 10, correct? So how many photon going to strike the surface? 100, right? 100 photon, correct? Now, let's say the intensity doesn't change. Intensity is still 1000. Intensity is still 1000. But you increase the frequency. When you increase the frequency, what happened to energy in 1 packet? Maybe let's say it become 100 EV. 1 packet, the photon energy is 100 EV. But the amount of energy strikes the surface is still 1000 EV, 1000 EV. So 1000 EV, 1 packet is 100 EV. How many photon will reach the surface? 1000 divided by 100, because 1 packet is 100. only 1000 EV energy reach the surface every second. So 1000 divided by 100, only 10 photon will reach the surface. So what's the conclusion? Intensity never change. You never change intensity. But if you rise frequency, okay, you rise the frequency, the number of photons become what? Number of photons drop. But technically, we can use this formula. This formula also tells the same thing. Okay, the n is inversely proportional to the frequency. When intensity never change, frequency you rise, the n will drop. The number of photon will drop. Okay. Oh, another way we can talk about like a cake story. A cake. I used to tell this in the last time, the senior class, like a cake analog to a cake. Okay, what is cake? So let's say you have a cake. What a cake? You have a cake. Okay, the size of cake. The size of cake is intensity. Analog to what? Analog to intensity. Big says big. The size cake become bigger means the intensity get bigger. Okay, now you cut into slices. The size of a slice. The size of a slice is the frequency. The what do you call? The energy of one photon. HR. Energy of one photon, one slice. Okay. This is the analog law. So now let's say you never change intensity. You never change intensity. That means the cake size, let's say the original cake, you got 10 slices. Original cake. Intensity is I, frequency is F. You got 10 slices. 10 slices means you get 10 photon. Now, intensity doesn't change. Means what? The cake size is still the same. But now frequency you increase. Means what? You cut a bigger slice or smaller slice? You cut a bigger slice, right? Big frequency means big slice, big size. So you cut a bigger slice. So what happened to the number of slice? What happened to the number of slice? Drops, right? So when the number of slice drops, the number of slice depend to what? The number of slice is analog to what? The number of photon. So the photon will drop. The number of photon will drop. So this is something like a cake idea to understand. Okay. So intensity like the size of the cake. The size of one slice is energy kept in one photon. So you rise frequency, you cut the slice bigger size. Okay. So let's we adapt to this. Intensity is increased, frequency unchanged. What happened to the number of photon? Intensity increase, frequency unchanged. So the cake size get bigger. The cake size get bigger. Frequency unchanged means what? You cut the same size as last time. So how many slices you get? You get more slices, right? You get more slices means the number of photon is greater. Get more photons. But the size of the slice is the same. The energy in one photon, kept same, never change. Shike, do you get the idea?
Oh, yes.
Can, But I think technically I go use the formula. I feel the formula is look more convenient for me. Okay. Okay. So yeah. So this is the idea of photoelectric effect. So the F and lambda, the kept constant, increase the intensity of the radiation, does not change the maximum kinetic energy. Yeah. Intensity, nothing to do with kinetic energy. Intensity just affects the number of photons. Maximum kinetic energy only affected by the frequency. Okay. So increase the light intensity, simply increasing the number of photons following the unit area. This results in an increased photon. The incident photons still impart the same amount of energy. Okay. So if intensity radiation is kept constant, but the frequency is increased, photocurrent remains constant, but stopping potential increases. This a little controversial. Don't go for photocurrent. They will ask about, don't go for photocurrent. I think I want to throw this point out. You go for number of electron emitted per unit time, number of electron emitted per unit, or number of photon released per unit time. What happened? Number of electron released per unit time. Intensity of the radiation is kept constant, but frequency is raised. So what happened to the number of photon released per unit time, or number of electron released per unit time? Anybody? The intensity of radiation kept constant. That means the size of the cake is still the same, but the F is increased. That means the size of the slice get bigger. What happened to the number of photon? Number of photon drop. Number of photon drop. So number of electron released per unit time also decreases. Okay, decreases. But no change to the stopping potential. Photocurrent remain constant. I think you cut off this, you replace with number of photon. Exam, they're going to ask about number of photon per unit time, or number of electron released per unit time. In this case, what happened? Number of photon per release per number of photon or number of electron per release per unit time. What happened? Decreases. Decreases. Intensity constant, frequency increase, number of photon or electron release per unit time decreases. Okay. But stopping potential increases, because stopping potential depends on frequency. Okay. So this is a very important core idea and introduction of quantum physics. Okay. Photoelectric effect is the main experiment, which I think which really change the science world, the understanding about EM radiation. Okay, previously before 20th century, before 1905, before the photoelectric experiment, people thought light is a wave. But now, what happened? Now what happened? Light definitely is a wave. It's a wave, no doubt about that, because it diffract, refract, interfere. It's a wave. But now when you interact with matter, it behave like not a wave. So it behave like a particle. We call it as a particle. The light behave like a particle. Particle means like a photon. Photon is like one discrete unit, right? So we call particle. It act like a particle. So we'll come to a big confusion now to solve this problem. Light is wave, but why when interact with matter, it act as a particle? So later, this idea has been solved by another scientist. Okay, this problem, light wave, but why when you interact with matter, it become a particle, act as a particle. Later was solved by who? If you go further, solved by de Broglie. We call it de Broglie. De Broglie, another scientist, the third scientist who developed this quantum physics is after Einstein is de Broglie. He solved the particle, the issue. But we will discuss this later, not today. Okay, guys. So what you learned today? You learn about how Millikan helped Einstein to prove Einstein's idea. Okay, this graph asked a lot of times in exam. Stopping potential versus frequency, gradient represents what? H over E. You have to know this. And the x-intercept is threshold frequency. What is meant by threshold frequency? Threshold frequency is the minimum frequency required to release an electron. Okay. So what is meant by stopping potential? The minimum potential required to stop electron from reach a to reach a cathode and causes a zero photocurrent. What is stopping potential? A potential to produce zero photocurrent. Yes, stopping potential. Okay. So now that's all. That's the idea for today. Any questions?
Teacher, I have another question.
Yeah.
If the frequency increases, right, the kinetic energy of the electron will increase. Then will the photoelectric current increases?
That's the controversial part. Okay. What should be? What should be? You see, current is rate of flow of charge, right? Current rate of flow of charge, right? So current is found to be proportional to N over T. The number of electron comes out. Okay. So when the number of electron comes out drops, current should drop. Okay. So when you have same intensity, frequency is I, so N going to drop. So current predicted to be drop, photocurrent, because current is directly proportional to the number of electron released per second. Because current is rate of flow of charge. Current is rate of flow of charge. So charge is what? NE over T. So it depends to number of electron comes up per second. So number of electron comes up per second drops, current drops, photocurrent. Okay. Shike, you got idea?
Yes.
Okay, guys. So homework. Just go through these questions with answer. Okay, for to understand better. Okay, so I stop here. So I see you back tomorrow. We try to, after you go through these questions, this is very important, example 7. Then we try to do more questions to enhance the idea. Okay. Okay, see you back on tomorrow. Thanks.